Hello and welcome back to Algebra, or if you are joining this class for second semester, welcome to the class. So we are in semester 2, so that means everybody's starting with a fresh start. Your grades are starting over with semester 2, so keep that in mind. It's always better to start strong rather than play catch up throughout the semester. So keep that in mind. Fresh start, start strong, and keep up the hard work throughout the semester, and I think you will be happier doing it that way rather than playing catch up as the semester goes along. So we are in week 2, so you should be working in the week 2 folder this week. Last week we started a brand new unit, unit 5, and you learned about polynomials and monomials. So for your warm-up, we are going to go back to what you did last week and make sure that we're good on adding polynomials. So remember, a polynomial is more than one term, and we'll talk a little bit more about that as we get going in this recording, but did want to start with a warm-up. Remember, you should have your math notebook out. You do need to take notes as you watch this recording. You will turn those in at the end of the week. And I also would like for you to complete the warm-up question in your math notebook. So if you don't have your math notebook, remember you have that ability to click pause. And you can use the pause button throughout this recording. Use it to your advantage. If there's something that you want to spend a little bit more time taking notes on, just click the pause button. So for the warm-up, go ahead and click pause, and I want you to try this on your own. You're going to add these polynomials together. So click pause, try it on your own, and then when you're ready to check your work with mine, go ahead and click play. All right, so to add polynomials, what we're going to do is add any like terms that we see. So a like term will have the same variable. So it will have the same variable raised to the same power. That's what makes something a like term. So looking at these polynomials, the different terms, I see that there's this x squared term here, 6x squared, and there's another x squared term here. That means we can add those two terms because they are like terms. Then I see there's a 3x. Are there any other x terms? No. So we'll leave that as is when we go to add. And then remember, like terms can also be whole numbers. Whole numbers are like terms. So that -4 and -7 are like terms. So when we go to add all of our like terms, 6x squared plus another x squared will give us a total of 7x squared. Then we don't have any more x terms to add to 3x, so it's just going to stay 3x. And then -4 and subtract 7, and we get -11. So adding this polynomial, we end up with 7x squared plus 3x minus 11. So adding polynomials, look at that. We went from having 1, 2, 3, 4, 5 terms to only having 3 terms. So an advantage of adding polynomials is that we're simplifying the number of terms that we're working with. I'm going to go on to the next slide, so if you need more time, go ahead and click pause. All right, so as we jump into semester 2, I just wanted to start with going over some tips for success this summer, I meant to say semester. Whew, I'm getting ahead of myself, aren't I? Wishful thinking. So first thing, make sure you're checking your grades often. Go into that grades tab. Look at what your overall grade is, but don't stop there. Click on the graded assignments to open those up and see what you missed. So when I grade all your work, I'm always leaving feedback. And then remember, you have that wonderful opportunity of redoing assignments. So make sure that you are looking at what you missed in my feedback before you go to redo assignments. Also, make sure that you are checking the updates tabs daily. I might not be posting to the updates tab daily, but when I do, they're important messages and I don't want you to miss out on anything. So just when you log into Schoology, when you log into your math course, look over the updates. That's where you land and see if there's anything new. And then also make sure you're checking your emails and messages daily so you don't miss any important communications from me as well. Moving on. All right, so what are you learning about this week? as I mentioned, Unit 5 is all about polynomials and monomials as well. So this week, we're going to review what we did last week. What is a polynomial? Review adding and subtracting polynomials. That'll be reviewed because we did that last week. And then this week, you're focusing on multiplying polynomials. So let's jump right in. So first of all, what is a polynomial? So a polynomial is a sum of terms in which all the variables have whole number exponents and no variable appears in the denominator. So this is an example. Let's look at the example. I think sometimes it's easier to look at an example than it is to read a definition, right? So a polynomial is when we have more than one monomial. So a monomial is something like 3x squared. That's just one term. It's just one term. So that would be an example of a monomial, is when we just have one term. And in each term, we have special parts. So the 3 would be our coefficient. The 3 would be the coefficient, the x would be the variable, and the 2 would be the exponent. Another example might be like 120xy. That's another example of a monomial. It's just one term. It's just one term. So when we start adding and subtracting monomials together, we get a polynomial. And each polynomial has terms in it. So let's look at this example here, the 3x squared plus 2x minus 8. That's a polynomial. And we've got 3 different terms. 3x squared is one term, 2x is another term, and the negative 8 is another term. So specifically, the 3 in the 3x squared we talked about would be the coefficient. The coefficient is the number in front of the variable. So 2 would be the coefficient in 2x. And then we've got this constant term, negative 8. It doesn't have a variable, so it's called the constant term. So then, more specifically, we can talk about the leading term of a polynomial. So the leading term is going to be the term that has the highest degree. And when I say degree, that means the exponent. So you can think of degree as the exponent, the highest exponent. So look to see which term has the highest exponent. So in this case, 2 is our highest exponent. And that means the leading term would be 3x squared. This is the leading term. The leading coefficient would be just 3. But the leading term is the entire 3x squared. So keep that in mind. The leading term is 3x squared. It's the entire thing versus the leading coefficient. Those are different. The leading coefficient would just be, in that case, 3 is just the coefficient, which would be 3 from right there. So again, just to make sure we understand the difference between leading term and leading coefficient. All right, and remember a polynomial, all right, so let's look at some examples below and determine if these examples are polynomials or not. So the first one, x to the 7th power plus 2x to the 4th minus 5. Is that a polynomial? What do you think? If you said yes, you are correct. This is a polynomial. There's no negative exponents and there's no variables in the denominators, and there's more than one term, so it is a polynomial. What about this one? 5x to the negative 2 plus 1. Is that a polynomial? No, and the reason it is not is because there's a negative exponent, and we cannot have negative exponents in polynomials. So this negative 2 messes everything up. Next one, 2 over n. Is that a polynomial? It is not. First of all, we only have one term. And second of all, there is a variable in the denominator, which makes it not a polynomial. We can't have a variable in the denominator. The last one, 4a, is that a polynomial? What do you think? If you said no, you are correct. This is an example of a monomial. There's only one term, so that would be a monomial. So I'm going to go to the next slide, so if you need more time, go ahead and click pause. All right, so again, let's talk about some vocab. A polynomial is a monomial or sum of monomials. So the highest exponent of the variable determines the degree of a polynomial. So you're going to hear a lot of talk about what is the degree of a polynomial. And the degree is simply the highest exponent. So look through all the different terms and look for the highest exponent, and that will be the degree of the polynomial. So before I go on, I did just want to clarify here that a monomial is a type of polynomial. A monomial is a type of polynomial. So a monomial is just something that has one term, but you can have a polynomial with one term. Or you can have it as a sum of monomials. So moving forward, looking for the degree, you look for the highest exponent, and that is your degree of the polynomial. So in this example, 4x cubed plus 2x squared minus 7. The highest exponent is 3. It's the largest exponent, so that makes that polynomial have a degree of 3. Next, when we write polynomials, the best way to write a polynomial is in what we call standard form. In standard form is when we order the terms by degree in decreasing order. So to write a polynomial in standard form, you start with your highest degree and then decrease as you write all your terms. And then you always end with writing your constant term last. So here's an example, 2x cubed plus x squared minus 5x plus 12. So note that the highest degree 3 is the first term, then our second highest degree is 2, so we would write that next, and then minus 5x, and always writing the constant term last. So again, remember the leading coefficient is going to be just that number in front of your variable of your leading term. So the highest term, that leading coefficient is just the 2. So the leading coefficient is really easy to figure out when we write our polynomial in standard form, because it's going to be that first term, it will be the coefficient of that first term. So the leading coefficient, remember we talked about that on the previous slide, that the leading coefficient is different than the leading term. So this entire thing, 2x cubed, is the leading term. So 2x cubed is the leading term. The leading coefficient is just the 2. It's just the coefficient. Remember, the coefficient is a number in front of our variable term. So the entire thing, 2x cubed, is the leading term, and the leading coefficient is just the 2. The polynomial degree is always your highest exponent, so that would be 3 in this case. So the degree of this polynomial would be 3. And then the constant term is 12. So learning all these different terms, let's see if we can put that to use. So here is a polynomial below, 5x to the fourth minus x squared plus x plus 10. So first of all, is this written in standard form? It is written in standard form because we have our highest exponent term first, followed by, in decreasing order, you can see all the other terms with the exponents in decreasing order, with the constant term last. So looking at this polynomial, what is the leading coefficient? So first I want you to tell me what the leading coefficient is, and then also tell me what the degree of this polynomial is. So if you want to click pause and try this on your own, it's a great way to check in and see how you're doing. So click pause, try it on your own, and then check your work with mine. So the leading coefficient is going to be 5. So the leading coefficient is going to be 5. And that's because we look for which term has the highest degree, and we know that's 4. And then the coefficient is just that number. So the leading term would be the entire thing, 5x to the fourth. But the leading coefficient is just the 5. What about the degree? What is the degree of this polynomial? The degree, remember, is the highest exponent. So the highest exponent is 4, so the degree would be 4. It would be a degree of 4 for this polynomial. So I'm going to go on to the next slide. So if you need more time, go ahead and click pause. All right. So we learned one way to classify a polynomial. And one way to classify a polynomial is by the degree. So that's one way that we can classify polynomials is by the degree. In this example, you always look for the highest exponent, and that is your degree. So that's one way to classify polynomials. Another way is by the number of terms. So you can classify polynomials by the number of terms. So if you have one term, it's a monomial. An example would be 3x. If you have two terms, it would be a binomial. You have two terms. 2x squared is the one term, and the 5 is the other term. If you have three terms, it's a trinomial. We've got 1, 2, 3 terms. And then a polynomial is anything with 4 or more terms is a polynomial. So let's look at this bottom example here. I've got expression x to the 4th plus 3x squared. So how can you classify that expression? So tell me 2 ways that you can classify this expression based on what we just learned on this slide. So first, we can classify it by the degree. So by the degree, what would be the degree of this expression? So we look for the highest exponent. In this case, it would be 4, so the degree would be 4. What's another way we can classify this polynomial? Or I'm sorry, I didn't want to say polynomial. This expression. That would be the number of terms. So we've got 2 terms, and since we have 2 terms, we can specifically say that this is a binomial. So 2 different ways that we can classify that expression. Moving on to the next slide. So if you need more time, click pause. All right, so we did an example of adding polynomials in the warm-up. So let's look at an example of subtracting polynomials. So when we're subtracting, we really have to be careful with this, looking to find where the subtraction sign is. And then if there is a set of parentheses, we need to make sure that we are distributing that negative to each of our terms that comes after the negative sign in the set of parentheses. So what I'm going to do is I'm going to rewrite this entire expression, paying attention to the second half where I'm distributing that negative. So let's rewrite that. So we would have 5x squared. The first half, nothing's going to change, plus 3x minus 6. Now let's start distributing. So negative times this positive 3x squared is become a negative 3x. Then I've got a negative times a negative x. The negative times a negative becomes a positive x. And then a negative times that positive 5, that's going to become a negative 5. Now that it's distributed, now we can look through and identify any like terms. So I see there's a 5x squared, any other x squared terms, a negative x squared. Make sure that negative stays part of that term so that when we go to adding and subtracting, we're not missing anything. Any x squared terms? Any others? Nope. Okay, what other? We've got 3x, and then we've got a positive x, so we'll put those together. And then we've got this 2 constant terms, a negative 6 and a negative 5 that we can put together. So let's go ahead and combine all of our like terms. 5x squared minus 3x squared, that's a total of 2x squared. 3x plus 1x, that gives us a total of 4x. And then negative 6, and we're taking away 5 more, so that's negative 11. So there we go, subtracting that polynomial, and we went from 1, 2, 3, 4, 5, 6 terms to only 3. So take a look at the second one now and see if you can do that one on your own. Go ahead and click pause, try your work on your own, and when you're ready to check your work with mine, click play. So again, to subtract polynomials, we really want to look through and see where the subtraction is taking place. So here we've got our negative sign, the subtraction sign. We're subtracting all the terms that come in this set of parentheses. We're subtracting y squared, we're subtracting negative 8y, and we're subtracting 9. So the first thing I'm going to do is rewrite this where I am distributing that negative times each of the terms in that set of parentheses. So the first half, nothing's going to change. We've got 6y to the 3, we've got 2y squared, we've got negative y, we've got negative 11. Now we've got negative y squared. A negative times a negative becomes positive 8y, and negative times a positive becomes a negative 9. And I meant to say negative times a negative becomes a positive for that 8y. I don't know if I said that right, but all right. So everything looks good. Now we look at combining our like terms. So any other y cubeds? I don't think so. Any other y squareds besides this 2y squared? We've got a negative y squared. Again, that negative belongs to this y squared. And then y terms, do we have any y terms? We've got a negative y, and we've got a positive 8y. And then we've got a couple of constant terms. We've got negative 11 and negative 9. Again, note those negative signs belong with the term that it follows. So then we're just going to go through, add our like terms. I like to color code them, or sometimes you can put, like, if you don't have different colors, put a triangle around sets of like terms, put squares around others, put circles around others, something to differentiate so that when you go to add them, you can easily identify those like terms. So we've got 6y cubed, 2y squared minus 1y squared. So we're at positive y squared. Then we've got negative y plus 8y. So we're really at 7y now. And then negative 11 minus 19. So we're at negative 20. And that's that. So that's our final answer right down here. And this was our final answer up here. All right, so I'm going to go on to the next slide. So if you need more time on this one, go ahead, click pause so you can take good notes. All righty, so multiplying monomials. So multiplying monomials looks different, right? Instead of adding or subtracting, we've got just two sets of parentheses right next to each other. So how we're going to do that, there's two different ways. I'm going to show you on this slide the two different ways. One way is to simply, this one's pretty not as tough as the second one. So you're going to multiply the coefficients. So here we've got 3x squared times 6x squared. So we start by multiplying the coefficients. So we've got a 3 and a 6. Those are our coefficients. So what is 3 times 6? 3 times 6 is 18. And then we're going to add together the exponents. So 2 plus 2 is going to add up to equal 4. So we would have a total of 18x to the fourth. So again, how did we do that? First, we multiplied together our two coefficients. So we did 3 times 6 to get that 18, and then we multiplied together the variable terms x squared times x squared. And remember the rules, when we multiply together variables with the exponents, you add together the exponents. So it would be 2 plus 2 to give us the x to the fourth. So that's how we got 18x to the fourth. 18x to the fourth. So looking below at this example below, we've got a little bit more terms, don't we? We've got negative 3x cubed times x squared times 2x squared y to the 6. So we're going to follow this same pattern that we did below, where we're going to group together the like bases and then multiply. So group together the like bases and then multiply. So what are the like bases? So we've got two coefficients. So we're going to multiply those because they're the same type of term. We'll multiply those together. So negative 3 times 2. What does that give us? Negative 6. Then, what are some other like terms? So we've got an x cubed, and what are the other x terms? So we've got two sets of x terms. We've got x cubed and x squared. So remember, when we multiply exponents, they don't have to be to the same power like we have to have when we add them. Little less rules when we're multiplying variables. They don't have to have the same power. They don't have to be raised to the same exponent to multiply them. So what would we get when we multiply these? We would get x. Remember, we add together the exponents. So it would be x 3 plus 2, it would be x to the 5th power. And then we're going to do the same thing with our y terms. We've got y squared and y to the 6. So y squared times y to the 6. We couldn't add these together. We can't add y squared plus y6, but we can multiply those together. So y 2 plus 6, when we're multiplying, we add the exponents, we get y to the 2 plus 6 is 8. Now we're going to put this all together for our grand total, our grand product, I should say. So our coefficient is going to be -6. Our x term would be raised to the 5th power, and our y term would be raised to the 8th power. And that, my friends, is the final answer when we multiply together those polynomials. Want to keep going? Sure you do. Let's go on to the next slide. So if you need more time here, go ahead and click pause. That was the answer for the top one. Circle that. Okay, so how do we multiply a polynomial times a monomial? So here's an example. We've got multiply 4, that's our monomial, times 2x squared plus x plus 5. So all we're going to do here is take the monomial and we're going to distribute it times each term in our set of parentheses. Got it? So how would we do that? So that would equal 4 times 2x squared. We're going to multiply that times that. Then we're going to multiply 4 times the x. Then we're going to multiply 4 times that constant term, so 4 times 5. So let's do the math. So 4 times 2x squared, that just gives us 8x squared. 4 times x, that's already done. That's just 4x. And then 4 times that 5, that would give us 4 times 5 is 20. We're done. We multiplied the polynomial times the monomial. So again, it's all about distributing, remembering that term and how we distribute. So the second one, here's our monomial, 2x, and we're going to multiply it times 3x squared. Then we're going to multiply it by negative xy cubed. And again, just make sure we remember that negative belongs to this term. That negative belongs to this term. So let's do it. Let's do the math. So 2x times 3x squared, we'll do that in just a sec. I'm just going to write out our distribution here. And then we're going to add to it 2x times negative xy cubed. So let's now do the math. 2 times 3x squared is 6x squared. So if you can look at it right away and know, okay, I'm multiplying, oops, that's a 2x. I'm missing that x in there. I missed that. So it's not actually x squared because we will need to add together the exponents, and in that case we will really, this has like an invisible exponent of 1, 2x to the 1 power. So 1 plus 2 is 3, so it'd be 6x cubed. So if you can look at that and just know in your head, well, 2 times 3 is 6, and then remember that's raised to the 1, so that would be x to the 3rd. That's okay. You don't need to write out all these steps. Do what works for you. Then we're adding 2x times negative xy cubed. So again, it's going to be negative because we're multiplying a negative times a positive. So it's going to be -2. How many x's do we have? We've got 1 here and we've got 1 here. Add those together and they're squared. And then we've got the y cubed. And we're done. So again, remember your rules of multiplying together exponents with powers. So when you're multiplying exponents with powers, you look for the same bases. So if you have 2 variables that are x's, then you add together the exponents. So you add together the exponents when you have the same variable base. And that's that. So I'm going to leave some of it for you to continue to learn. I don't want this recording to get too long this week. So you'll also be learning how to multiply a polynomial times a polynomial this week in your Schoology lessons. So make sure you're paying close attention to the Schoology lessons and writing down examples. And we are ready for the key phrase assignment. So I've got a expression below, and in order to get credit for watching this recording, you need to complete the week 2 key phrase assignment. That assignment is on the next page to a slide from where you found the link to this recording. So on the next slide you will find the key phrase assignment, and you need to answer this question in order to get points for watching the recording. So here I've got an expression, 3x to the 5th power plus y to the 4th plus 2y to the 3rd power minus 2y plus 5. So I want you to classify that expressions in 2 ways. So first I want you to tell me what is the degree of this expression. And then for the second part of the question, you need to tell me the leading coefficient. Not the leading term. Remember, the leading term and the leading coefficient are different. And if you need to review that, go back and watch the recording because I did explain that. So tell me what the leading coefficient, not the leading term, what is the leading coefficient of this expression? And that's it. Let me know if you have any questions or if you need help with anything this week. Remember, I'm here to help. So ask questions. Asking questions is super important in your learning. Have a great rest of your week.